and min problems, they're all going to be word problems this entire unit. That's what makes it hard, yeah. So it's taking all the stuff that you've learned so far and putting it towards word problems. So here's what you need to remember. When you take the derivative, what you're going to basically do is you're going to set up a function for yourself. You're going to take the derivative of that, and you're going to set it equal to 0. And when you set that equal to 0, then you will find your maximum or minimum points depending on what the graph looks like. If it's concave up, you'll find minimums. If it's concave down, you'll find maximums. Okay? You can do that with the derivative if it's easy to do. Well, a lot of them will be. Sometimes, though, we're just not going to do the derivative. We're going to take the function and set it equal to 0, find the maximum minimums graphically, like old school. Okay? Now, back in the day, before Leibniz and Newton, you couldn't do that because no one had a graphing calculator in the 1600s. So they'd have to graph these by hand and try and find the horizontal tangent lines. I know, right? Okay, so here we go. This is what you're going to do. Now, the book goes through this whole strategy for solving max-min problems. Number 1, understand the problem. Number 2, develop a model. So we're going to, write an equation for this. You can draw pictures, label parts, use a variable. Then we're going to take the derivative, set it equal to 0. If we can't, we will graph it and find maximum minimums, and then we're going to interpret our solution. Okay, so here we go. Find two numbers whose sum is 20. Let's say one number one number is x and the other is y, and they add up to 20. Okay, so far so good. Now, these two numbers, x and y, we want to find the maximum product of the two of them. So let's take m and say that we want to maximize x times y. Now, a lot of times with these problems is you're going to have two variables, but you don't want to take the derivative with two variables. It's bad. So what you want to do is you want to take your first equation and solve one of those for one of your variables. So let's just solve it for y. Sure. All right, so y is equal to 20 minus x. And then we're going to simply use substitution. And we're going to take 20 minus x and plug it in over here. So we want to maximize x times 20 minus x. And if we go ahead and distribute the x, then m is equal to 20x minus x squared. And we all know that that is the graph of a parabola that opens down, so there will be a maximum. Okay? So here we go. Take the derivative. The derivative is so beautiful. You take the derivative and you get 20 minus 2x. Set it equal to 0 to find out what x is. So we can add 2x to the other side. 2x equals 20, so x is 10. Now it says find two numbers, so make sure you go back and read what they're asking for. We want both numbers that add up to 20, give us our maximum product, and so y would also be 10. You said that already. You knew that.
You just did all this extra stuff to just
Well, I know this is an easy one, but sometimes they're not that easy. One could be twice as much as the other plus 3 or something, and then you have to do the whole process, and it's a little harder.
I have a question. So,
Yeah.
on a quiz.
You have a question?
Shut up.
He's paying attention. Leave him alone. Yes.
Partially.
It's fine.
Hey.
So a rectangle is drawn under a sine curve, one arc inscribed. What does that all mean? Okay, here we go. Let's go ahead and draw a sine curve. They want just the first arc of the sine curve. Now, do you remember how to graph a sine curve? You go 1, 2, 3, 4. That's 2 pi, and this is pi. And then if you remember, sine goes through the origin. My first tick mark, I'm up here at 1. I'm down here, down, back. All right, here it is. There's the sine wave. Now, I'm really good at these because I just taught these in my other class, but maybe you are because I taught you this last year. Okay, we want to find, what we're going to do is we're going to kind of blow up just this first arc right here. And we're going to draw a rectangle. And we want to draw the rectangle that's going to have the largest area. So what I'm going to do is this. I'm going to redraw this real quickly over here, just so it's like bigger. So let's say it looks like that, okay? I don't even care about the rest of it. So here's my rectangle. I'm going to draw any rectangle I can. That's going to be the one with the largest area, okay? But it's really important to know that that first tick mark is pi, because you're going to need that. Okay, now let's go ahead. What we need to do is we need to find the dimensions that produce the largest area. So I want to maximize the area. I'm going to take the derivative of the area and set it equal to 0. But I need to know what the dimensions of this rectangle is. Here's how you do these problems. From 0 to out here, you want to label that as x. Okay, no matter where your thing's inscribed, from the origin out to the first part of the box, you want to say that that's x, which means that this side is also going to be x too, because it's a rectangle. It's going to be symmetric in there. So then that means that the side, the length of this rectangle is what?
Just pi minus 2x.
Perfect, Trevor. Pi minus 2x. It's pi all the way across the line. From the origin out to here is pi, but I want to subtract off each of those yellow x's, so minus 2x. Now, the hard one is, what's this? And don't tell me it's y. I mean, you are right, it is y. No, you know what that is? That side right there. If I were to plug, well, it's going to be the height of this y variable right here. If I plug x into, what's this function? Y equals sine of x. Y would equal simply sine of x. That's the height of the rectangle.
And so why is that?
Yeah. Okay. So this right here, since I labeled this as x, this point right there is the point x comma y, right? This point on the graph is x, y. Well, I don't want it in terms of y. I want all of it in terms of x. So if this is the point x, y, and then my graph, I know the graph is y equals sine of x, then that's simply the point x comma sine of x. All the points on that graph are x sine of x. And so this one, since this is x to here, then the y is the height, is just sine of x. So then the area of this thing would be sine x times pi minus 2x. Because it's length times height. Or length times width, whatever you want to call it. Okay, so now at this point, we would have taken the derivative of this, but they say, and I will tell you, you can do this graphically. I'm not going to make you take the derivative and set that equal to 0 because it has a sign in it. So we're going to go to our calculator now, and we're going to graph this function. And we're not going to find the zeros of it because it's just the function. We're going to find the maximum of the function itself. Yeah, so get your calculator out. Mine's over there.
And why is it the maximum?
We're looking for the maximum possible area of the rectangle. Yeah, that's what it says in the problem. What dimensions produce the largest area?
Can we just graph this?
Yeah, so you just simply graph that. So sine of x, close the parentheses, times parentheses pi minus 2x. Make sure that you are in radian mode. And then you can just hit zoom trig. Ooh, nice.
Should we zoom in
Um,
on this little curve right there?
you're not going to need to. So for this graph, it ends up looking like it goes like way down and that, and it goes through here, and it goes way up here. Okay, what we're going to do, the maximum is always going to be that first x that you get right there. Anything else past that is going to make the length negative. Right? Like you're like, but that x, wow, that's really far out there, you know, but we don't want that one because if I did this pi minus 2 times that x, that's going to give me a negative. So I always want this first one I see right here. So calculate the maximum. So left bound, right bound, enter, x equals 0.71. That's the other thing. These are always going to turn out like not nice answers. Okay, so this x right here is where x equals 0.71. But let's go back and look at what the question's asking. What dimensions produce the largest area? So I need to then go back and do pi minus 2 times 0.71. That's going to give me the length, the flat part on the bottom. So pi minus 2 times 0.71 gives me about 1.72. And then the y, the height, is just sine of x. So sine of 0.7 is 0.65. So 0.65. So it's a 1.7 by 0.65 rectangle. That'll give me the largest area. Pretty gross, huh? So then, yeah, the height is going to be this, which is sine of x. So I ended up doing, to find the 0.65, I did sine of 0.71 was 0.65. So this is 1.72 is the base, and 0.65 is the height. And that'll give me my maximum area inscribed in the sine arc. Good times, huh? Yeah, it's not nice when you get something that you can't take the derivative of and set it equal to 0. You graph it, and you know, they did all that by hand back in the day. All right, the next one's going to be really nice. You're going to like this one. Okay, there we go. A rectangle is inscribed under the parabola y equals 30 minus x squared. So let's see what that looks like. Here's the parabola. Y equals 30 minus x squared. Some people don't like it written like that. You can write this as negative x squared plus 30. That might help you figure out what that looks like. Do you know what that looks like? Perfect. It's an upside down parabola at 30 pointing down. Perfect. I would hope that you guys would know what that looks like without having to graph it on your calculator. Okay, it says here, its base, a rectangle is inscribed under the parabola, and its base is on the x-axis, and the upper two vertices on the parabola. So this is what the rectangle looks like. It's like this. The base is on the x-axis. This might not be the rectangle, but that is a rectangle. It might be that. It could have been this one right here. Maybe this one is the one that is the most area. I doubt it. Or really tall and skinny. Yeah, maybe that one could have been it. Okay. I'm just going to go with the blue one, though. Do I have to redraw that then? Yeah.
Can you hit backspace twice?
Yeah. You want me to do that? Just get rid of it. Oh, no. Too far. All right, there we go. Okay, so now I told you on the last one, and it's going to be true for all of them. What you want to do is you want to make from the origin out to the part of your box, no matter if your box is on the other side or your box contains that, you want to make that x. Okay? And the reason why is because this right here is going to be the point x, and then x what? xy. And what does y equal? Negative x squared plus 30. Because it's on that parabola. So that means you have your base and you have your height. Maybe you don't know it though. Do you see how you have your base and your height? What's the base then? 2x. Perfect. So the area would equal 2x, and then your height is the y, which is negative x squared plus 30. Oops, I don't want it in that color. Negative x squared plus 30. Or 30 minus x squared, whatever you want to say. Okay, so now this one, we can go ahead and take the derivative of this one. So it's up to you. Do you want to use product rule? Probably not. Go ahead and just distribute first to simplify your equation. So you get negative 2x cubed plus 60x. And then anytime you want to get the maximum area or the minimum of something, you always take the derivative, set it equal to 0. So the derivative would be negative 6x squared plus 60. Okay, take that and set it equal to 0 and solve. I would probably add 6x squared. What's that?
Plus and minus squared.
Yes, plus and minus, and then we'll talk about which ones it's going to be. And then x squared would be 10, so x would be plus or minus rad 10. Okay. Oh, did I do that right? No. Yeah? Oh, okay. Yeah. Perfect. All right. So it's definitely not going to be the negative because, right, your base is 2x. Do you really think you're going to have 2 negative rad 10s as your base? No. So we can throw that one out. So if you forget to take the plus and minus, then you're actually better. All right. So then the base of it, which is 2x, is going to then be 2 rad 10. The height is negative, well, it's 30 minus rad 10 squared, which is 30 minus 10, which is 20. So let's go back to the question. It says A, find the maximum area, and B, the dimensions. So the dimensions would be, it's a 2 rad 10 by 20. That's the dimension of that rectangle. And the area would be just to take those and multiply them. So the area would then be 40 rad 10. Exactly. Wasn't that a good one? You liked it. The hardest part for these, I think, for people is setting up the equation. You guys know how to take derivatives. You know how to solve and set it equal to 0. That's the hardest part. All right, 2 more to go. These ones are super fun. To that big packet I gave you. We're gonna spend the next week or 2 doing that. Okay, here we go. You're gonna work on a farm, so you gotta know how to do this problem. Suppose you have 400 feet of fence to make a large rectangular pen with 2 partitions. So maybe you have some pigs or some chickens that you need to put in a little pen, and you want to give them the most area possible before you eat them. So what is the largest area that can be enclosed, and what are the dimensions? Okay, here we go. I labeled this as X, and the whole thing on this side is Y. That means that each of these is also X. Okay, so we have fencing. Our fence has to go around the entire thing and then through the pen twice because maybe all your animals can't be together. Okay, so all the fencing that we have is going to add up to 400. So what would I write for that? I would write, how many X's do I have? 1, 2, 4X plus 2Y gives me a total of 400 feet of fencing. And then I also want to maximize the area. What's the area of this entire rectangle? Perfect. It's X times Y. Okay. So I'm going to take the derivative of area, but I'm not going to do that with 2 variables because that's gross. What I'm going to do is I'm going to go up here to the first equation, solve for a variable, substitute it back in, then do the derivative. Yep. Okay. Here we go. Let's solve for Y. We'll subtract 4X to the other side. So this is 400 minus 4x. Divide everybody by 2. So y is 200 minus 2x. Okay, take that and substitute it into here. So area equals x times 200 minus 2x. Nobody really wants to do product rule probably. So let's go ahead and distribute, get rid of the parentheses there. So then the area equals 200x minus 4x squared. It's an upside down parabola, okay? The books really, they stress the importance of taking the second derivative and seeing if it's concave up or concave down. I don't do that. I do problems that actually are gonna work. You are finding the maximum. Oopsies. I thought you guys were looking at me like I was
Oh,
wrong.
the exact same thing.
Good, yeah. It is 2x squared.
Oh, wait.
Thank you.
Oh, no, I think we probably skipped over to like doing the derivative.
When you take the derivative ends being 4.
Oh, yeah. I was thinking ahead. Or I just made a mistake because I'm an idiot.
Don't call yourself an idiot.
Don't. Yeah, I say that every day to people. All right, so go ahead and now take the derivative. So we get 200 minus 4x. Set it equal to 0 and solve. So 200 minus 4x equals 0. And a lot of times, like on your tests and quizzes, I like these to come out nice. I do. I like them to be nice whole numbers so everyone feels real warm and fuzzy. 4x equals 200. So x is 50. Yes, I was going to say that. Okay, now, what is the largest area and what are the dimensions? Okay, so this is going to be, x is 50, then that means y would be 100. Okay, you go back to where you solved for y. I looked at it right here. Y was 200 minus 2x. So those are my dimensions, a 50 by 100 pen. And then the largest area, and that's up to you. You can go to x times y. You can go to x times 200 minus 2x. Don't go to the derivative, though. You don't want to plug them in there. But the area would then be 5,000. Oh, and don't forget units. So that's 5,000 square feet. And these are both in feet also. Yay, aren't these fun? We get to do these for like a couple weeks. They're so fun.
Why'd you say you, to do the arrow, you put it back and then
To do what?
plug it? Why'd you say it doesn't matter which one you plug?
Yeah, so there I have two area. I have area as x, y, and then I also have area without y in it. You could plug it into either one. I would just choose x, y. Yeah. All right, last one. Last one for the day. What is the smallest perimeter? Ooh, we're finding the minimum now. We haven't found the minimum yet. That's what I was saying before when you guys were like looking at my mistake instead of listening to me. I was saying that it's either going to be concave up if it's a minimum or concave down. But I don't have you don't need to check that because I'll have it work out the way it should. All right, what is the smallest perimeter possible for a rectangle whose area is 100 square inches, and what are its dimensions? Any guesses? Yeah. Okay, so here we go. Let's say that we have a rectangle, and our rectangle is x, y. And this rectangle has an area that's 100. So x times y equals 100. This time, we're trying to get the smallest perimeter possible. Maybe we don't have that much fencing to use, so we want to use the least amount. So then the perimeter would equal 2x plus 2y. Perfect. Okay? But we have to take the derivative of the perimeter to minimize it. But before we do that, we need to go to our first equation and solve for a variable, plug it in so that we're only taking the derivative with one variable. So let's say that y equals 100 divided by x. These are a little bit tougher because the derivatives are going to be a little trickier than just parabolas and cubics. So y equals 100 over x, plug that in right here. So then the perimeter would equal 2x plus 200 over x. Is everyone okay with that so far? Okay, so 2x plus 200, x to the negative 1. You don't need to use quotient rule. Okay, it's a constant over a variable. You just can change it to x to the negative 1. And now let's take the derivative. So the derivative perimeter would be 2 minus 200 x to the negative 2. So we're going to get 2 minus 200 over x squared, and we're going to set that equal to 0 and solve. All right. So we need to solve this. So let's add that negative 200 over x squared to the other side. So I get 2 equals 200 over x squared. We can put that 2 over a 1 and cross multiply. So 2x squared equals 200. Divide by 2. x squared is 100, so x would be plus or minus 10. We're talking about a real live dimension, so we want to get rid of the negative. So x would be 10.
Y equals 10?
Yes, it's a square. So then go back up to where y is equal to 100, divide it by x, and you get that y is 10 also. And then what is the smallest perimeter? 40. Perfect. You go to wherever you have perimeter at, which is 2x plus 2y, and you will get 40. And then don't forget, these are in inches this time. So the smallest square, or the smallest rectangle that you want to make is actually a square. They'll use up the smallest fencing. Okay.